Welcome to Spaceverse, your portal to cosmic adventures. Imagine staring into the vastness of space with the Hubble Space Telescope, only to see complete darkness. But when astronomers pointed the James Webb Space Telescope at the exact same region, something extraordinary appeared, a faint, eerie red glow. Hidden within the cosmic shadows was a ghostly dust-shrouded galaxy. This mysterious galaxy, known as Aztec C71, is one of the most distant ever discovered, offering a rare glimpse into the early universe. In today's video, we're diving deep into this incredible find, why it matters, what it tells us about the cosmos, and how scientists uncovered it. So what makes Aztec C71 so special? To truly understand it, we need to measure its key properties, things like its mass, brightness, color, and distance. These factors help astronomers piece together the galaxy's story and its role in shaping the universe. To do this, scientists rely on James Webb's near-infrared camera. This powerful instrument captures images of the sky in different wavelengths of light. By analyzing how the galaxy glows through various filters, astronomers can estimate its distance, temperature, and even its chemical makeup, a process called photometry. So, what secrets does this ghostly galaxy hold? Stick around as we uncover the science behind this astonishing discovery. The photometry results reveal that this galaxy is an absolute giant, both in size and brightness. It has a staggering mass of 50 billion suns and shines with the intensity of 500 trillion suns. These numbers put it in the same league as some of the most extreme dust-obscured galaxies ever discovered, often called submillimeter galaxies because they emit most of their light in the submillimeter wavelength range. But what makes this discovery even more fascinating is its distance. The galaxy's redshift of 5.7 tells us that the light reaching us today was emitted when the universe was just 1 billion years old, a mere 7% of its current age. Due to the universe's expansion, this ancient light has been stretched into the redder wavelengths, making Aztec C71 one of the reddest galaxies found in the Cosmos Webb survey, a massive sky survey covering a region 10 times the size of the full moon. What's even more intriguing is that this galaxy is almost invisible in optical and near-infrared light, the wavelengths that telescopes like Hubble rely on. That's because it's buried under a thick blanket of cosmic dust, which blocks much of its starlight. Instead, the dust absorbs this light and re-emits it in far infrared and submillimeter wavelengths, exactly the range that SCBA2 and ALMA can detect. These telescopes were the first to spot this hidden giant, but they couldn't determine its shape or measure its distance. That's where James Webb came in, revealing the full picture of this ghostly, long-lost galaxy. Despite being nearly invisible to Hubble, the James Webb Space Telescope managed to detect the rest-frame optical light from this galaxy, essentially the visible light it originally emitted before being stretched by the expanding universe. This light is crucial because it holds key insights into the galaxy's stellar properties, including its age, composition like metallicity, and star formation rate. So how did Webb succeed where other telescopes failed? It comes down to two major advantages: its superior sensitivity and resolution, and its ability to see in longer wavelengths that cut through cosmic dust. With its near-infrared camera, Webb could unveil details that were completely hidden before. Aztec C71 isn't just another distant galaxy, it's a rare and puzzling discovery that challenges our understanding of how galaxies evolve. One of the biggest mysteries is why it remained completely invisible to optical telescopes while being detected in the submillimeter and far infrared wavelengths. To solve this mystery, we need to look at what makes this galaxy so incredibly dusty and red, and it all comes down to an extreme burst of star formation. This event, known as a starburst, is when a galaxy forms stars at an explosively high rate, sometimes hundreds or even thousands of times faster than normal. But what triggers a starburst? It can be caused by things like galactic mergers, massive gas inflows, or intense stellar feedback. And the effects are just as dramatic. It can drive powerful outflows of gas, enrich the surrounding space with heavy elements, or even shut down star formation entirely over time. Aztec C71 is a galaxy in the midst of cosmic upheaval, offering a rare glimpse into one of the most intense periods of galaxy evolution. And thanks to Webb, we're finally seeing it in a whole new light. The intense starburst in this galaxy is creating huge numbers of young, massive stars, blazing hot and incredibly bright. These stars flood their surroundings with ultraviolet and optical light, the same kind of light that telescopes like Hubble are designed to detect. But here's the problem. This high-energy radiation doesn't just shine outward, it also heats up and ionizes the surrounding gas and dust. Over time, these particles clump together, forming thick, dense clouds that act like a cosmic smokescreen, blocking the star's light from escaping. This is why the galaxy remains invisible to optical telescopes. However, the story doesn't end there. Instead of simply absorbing the light, the gas and dust clouds reprocess it, transforming the energy into much cooler wavelengths, specifically far infrared and submillimeter light. These longer wavelengths can slip through the dusty veil, which is why telescopes like SCBA2 and ALMA were able to detect the galaxy, even though Hubble couldn't. But there's another factor at play: the expansion of the universe. Space itself is stretching, which means that as light travels across vast cosmic distances, its wavelength gets longer, a phenomenon known as redshift. Because this galaxy is so far away, its original light has been stretched into the infrared, making it appear deep red when viewed from Earth. Aztec C71 isn't just any galaxy, it's an extreme, elusive cosmic oddity that challenges astronomers to uncover its secrets. But how did it form, and how does it compare to other galaxies in the universe? One possible origin story is that Aztec C71 was born from a violent merger of two or more smaller galaxies. When galaxies collide, their gas and dust get compressed, triggering a massive wave of star formation, a starburst. These mergers also churn up enormous amounts of dust, as old stars are destroyed, releasing heavy elements into space. This could explain why Aztec C71 is so bright and massive. It's the combined result of multiple galaxies merging into one. Another possibility is that Aztec C71 grew by pulling in gas from the intergalactic medium. This process, known as gas accretion, is much smoother than a galaxy collision, but it can also fuel a starburst by providing fresh material to form new stars. Over time, this inflow of gas can also generate dust, either by carrying in existing dust particles or by creating them through stellar processes. Like a merger, gas accretion could be responsible for the galaxy's huge size and luminosity, as it continuously absorbs and converts new material into stars. Whether through chaotic mergers or steady gas inflows, Aztec C71 has grown into one of the most enigmatic galaxies ever discovered, and understanding its journey can help unlock the mysteries of galaxy evolution across the cosmos. And that's it. Thanks for joining us on this deep dive into the mysterious galaxy Aztec C71. Its hidden glow, extreme starburst, and dusty origins challenge everything we know about galaxy evolution. What other cosmic secrets are waiting to be uncovered? If you enjoyed this journey through the cosmos, subscribe to Spaceverse and stay tuned for more mind-blowing discoveries. Until next time, keep looking up.